Hello, we're working on Chapter 7 in our book, and you can see the topic for the chapter is basically looking at characters and strings and things related to those data types and objects. Here is a brief overview of the chapter and its main topics. So we're going to be looking at each one of these. If you look at the number of slides down here, there are 44 slides, but some of them are going to go pretty quick. I know that I've talked about some of these topics, and I'm going to try to focus on things that we really haven't talked about a lot, and more importantly, focus on the things that you need to successfully complete your homework. So let's move on. All right, now we learned in earlier chapters, and I think it was chapter 2, and we went into data types, or maybe it was even chapter 1, that Java, like most languages, has certain data types that we use. And, just for example, an int for an integer, and a double for a double, and a character. And we kind of have been using strings as a data type, but the reality is they're not data types. They are a class that is got a whole range of features that go with it. We use it as a data type, and if you think about it in that capacity, it also kind of should help you unlock the fact that Java, being an object-oriented programming language that uses objects and classes very heavily, when you see some of the ways that we use a string, it should start to unlock other objects and classes for you in the way that you utilize them, and maybe in a way that you didn't look at them before. All right, so you're going to ask yourself, so why is a string not a primitive data type in Java? The reason is because the actual primitive data type is a character, the char. So one single character that's not a number, right? So even if I had a number, it's actually a character. Like when we type it into a form or put it back up on the screen, it's actually a character at that point. But a string is a collection of characters, or really a better way to say it is it's an array of characters. That's what a string is. Right? So now, because it's also a class that has a lot of different things associated with it, think of the class files that you've built so far. You build a class, and then you'll have data fields or variables way at the top of the class typically. And you'll have like sets and gets and all those kind of things. And then sometimes you have methods that are written within, and the string class is no exception to that. So it has attached to it a number of other methods that you can utilize and leverage to your advantage to manipulate strings and do a lot of things that you might not think that you're able to do. And they're really there to kind of help you do a little bit of time saving on your work. All right. Yeah, I'm not sure what to say aside from that on that slide. All right, so when we're working with strings, one thing that we're going to be doing, one of your assignments I think also does this, is comparing strings. Like for example, think of like when you go to a website and you log in, right? And you type in the password. Somewhere there's a comparison going, is this string the same as this string? And the operator that you use for that is the equal sign. When you use the equal sign singly, as with any other variable or data type, you're assigning a value as opposed to comparing if they're equal. But notice it says you're not comparing values, you're comparing computer memory locations. So you're looking at one spot in memory, and you're looking to see if the data in that spot in memory is equivalent to the other spot in memory. Yeah, and it says compare the contents of memory locations more frequently than memory locations themselves. So we don't usually think about that, but anytime we declare a variable of any sort, the reason we're declaring it is because it reserves that spot in memory for that information. Okay, so let's continue here, and I want you to get a really clear understanding of how the string comparison thing works. This slide that we're on right now, notice the slide above. The equal is not comparing the values. And I want to, I guess, say it slow like that to kind of emphasize it. You're comparing computer memory locations. We just said that, right? If you look at the next slide, notice a little thing here. When we're doing like an if statement, we're checking to see if one string is equal to another string. What does it say? Don't do it. Don't use equal to compare string contents. It's comparing the memory locations. The reason that is because this is a class and not a primitive data type. All right. So if we're actually going to do that, we're going to use a different approach, and I'll show you how that's done shortly. All right. So when we work with these additional classes, notice we have a primitive data type that's just called that, right? Character. But there's actually a class called character too. And the reason we have a class for it is because it extends the capabilities. So in other words, it gives us methods that are attached to it that we can, once again, leverage to our advantage programmatically, where just the very simple primitive data type of car, or whatever you want to call it, doesn't have those capabilities. It's just a way to hold the information. Some additional classes that we're going to look at are these two, and these are very important ones, the string builder and the string buffer. We don't really make extensive use of them, I think, in this class, if I remember right, but if you are interested in different ways to bring information into your program, string buffer, for example, is one way that you can do it. But you can see that it says classes for storing and manipulating changeable data composed of multiple characters. So you may use this to take the letters that are in the string, switch them around, or order them, or capitalize them, or things of that nature. The character class has a bunch of different methods in it, and one of the things that we use very commonly, and you probably have seen these already, are ones like this. And you see this in other languages too. Is and to, and basically the is the one that checks to see if something is a certain way or not. That's why it's an is. So is it uppercase? And what do you suppose that returns? It says right there, Boolean, true or false, right? And then maybe you would write something and say, is it uppercase? And if it's not, make it uppercase. So if is checks it, to converts it. And the word itself isn't magical, but that's the convention that's used in classes and across languages. So as you can imagine, there's many different methods that are embedded into these classes, and here's some very common ones that we use. Uppercase, lowercase, is it a digit, is it a letter or a digit, is it white space? Did you ever wonder that when you type in a string, does it count the space? Sure it does. When you type that in on the keyboard, that has a character code just like the letter does that's sitting next to it. Okay, let's see if I can zoom in on this code just ever so slightly. And I'm not going to logic through the code, but I just want you to take a look really quick and take a look at some of the stuff that they're doing. For example, is uppercase. Notice that at the beginning of this phrase, right here where my cursor is, it says if character is uppercase, where's this being declared, character? Do you see it anywhere? Do you see me creating a class called character? You don't. It's built into the language like string is. So typically, we don't actually see us using it in this capacity. But the point is that with string, we don't usually use it either, but we just invoke it because it's part of the language. It knows where to find it. And this is what I'm hoping will maybe unlock a couple of doors for you, because really somewhere there's a file called, public class character. It's got all this stuff in it, and then we use the name of it and we call upon any of the stuff that it can do, like is this uppercase? Very often, though, we'll omit the character part and we will just say, is that uppercase? And just use it, and it works. All right, so that's one of the things we're trying to show you here. If you want to have fun, you can take this and drop it into your program and try to make it go and see what it does. It's up to you. All right, we use this term quite a bit, and sometimes I use it and don't think about it because I've used it so much for so long. But I want you to be aware of what literal means. When something is literal in regular language, what does it mean? Like if somebody goes, literally, like it actually is, right? Not figuratively, which is it sort of is, or this is what I sort of want it to be. It literally is. But the thing with the string literal is we're not using any of the, the class types to define it. We're just using it. So like if we do like system out print line and we put in a string, the string that's inside those parentheses is a literal string. We're not defining the string or storing it somewhere. We're just using it. We can do the same thing with numbers as well. So when we hard code something directly, it's a literal. So when you hear somebody say string literal, that means I didn't put it in a variable, I just did it. Okay, it's kind of like an anonymous function or a method if you want to kind of think of it in that capacity. All right, now, so literal string, unnamed object, anonymous object, it's part of the string class. The string class has built into it the capability to allow that to happen. And that's why the language can do it. Now the reason that you do that is so that you can kind of take shortcuts and write code in a higher level sort of way. All right, so we can also use string as a variable, and that's probably what you're used to. Like you'll go string my name equals Joe, right? So we can use it in that capacity. So think about what's actually happening there. We're not using a primitive data type, we're using a class. And really what's happening is we're invoking a constructor function that's kind of invisible to us. And I'll show you what I mean. In fact, probably a good way to show you what I mean is to do something like this. Like for example, if we're in a program, I might go my name equals Joe. All right, we just use it like it's a data type. But in reality, what we're doing is because string is a class, it's really doing this in the background and you're not realizing it. Those are basically the same. So really what we're doing is we're creating a new instance of string. So I hope, okay, we've kind of turned the key a little bit and we're unlocking a door here of understanding, I'm hoping. So you can see that, that in action, I guess is the good way to say it. All right. Now, why does that work? That's because string is part of the core Java language. That's a class that's just built in. We don't have to import it. It's just there. All right, so I think you guys know how to declare a string. Look, they stole my thunder. There it is. All right, but really, like I said, these two things are functionally equivalent. But of course, we choose this method because this is easier, right? And it compares very well to other languages. String is a class, we said that already. Assign a variable name to it, put a new value in it. I think that's all pretty intuitive. All right, but part of what we'll do when we are comparing strings is we're going to start using a couple of different methods that are attached. So they're doing a little bit of a comparison here. So take a look at this side here. So they have string a greeting equals hello. So what happens is memory location 10876 named a greeting holds a certain value, right? This is stuff that you want to like blot out of your head. You just want to code, right? But at times having understanding of this stuff is pretty interesting. Now, when I not first started coding, but as I started coding, I had to take assembly language. You guys should thank your lucky stars you don't have to take assembly language, because it's one step above machine code. We weren't writing the code with ones and zeros, we were writing it with slightly higher than ones and zeros, but not much. So one thing that you had to know was the memory addresses where you're putting things, and copying them, and storing them, and recalling them, and and not a fun process, but thank you for high-level languages. All right, so notice on the opposite side, they're going to do a comparison. Once again, they have the same memory address, but notice that this address will have these different values, right? What is XXYYZZ223? What do you think it represents? Garbage, basically. Have we used that term yet? If something isn't stored in a memory location, the stuff that's sitting there unused is called garbage. And then if I use a variable just in a method for a short bit, and then I move on to something else, what happens to that memory location? That stuff still sits there, even though I stop the program. And really, computer memory will only go away once I turn off the power. So if something is not rewritten to that space, or maybe it is, maybe it's partially rewritten, or who knows, then it becomes garbage if we try to output what's there. So notice the values inside here and how they point. So they're trying to show to you that you address things actually by memory location. And this is the equal, equal, and the equal sign. So when we're doing our comparison, we have to make sure we're comparing what's inside as opposed to what's not. But the way the computer keeps track of it is via memory location. It points to where we're going. Don't worry, it's not on the final. I see the blank stare, so. What does it mean to be immutable? Cannot be changed. Okay. All right. What kind of objects within a programming language would not be changeable? How about constants, if you declare constant? Right? Okay. All right. So the point of this is, it says objects that cannot be changed, such as a string. If I have a string literal, it is what it is, and I can't change it because I didn't store it somewhere where I could change it. Okay. If you're going to do comparisons, you get those weird results because the way the operators work. Once again, compare memory addresses, not values. You can see it's a recurring theme. So what they've done is they've actually written methods that allow us to compare the strings and kind of make our life a whole lot easier. So there's a number of them that you're going to see here as we step through the slides. And at this point, a lot of what's in the PowerPoints is just here's a method, here's a method, here's a method. So I'm hoping I can kind of go through it pretty quick. And if you really get stuck on one, just shout out and I'll try to address it. So here's the first one. The equals evaluates the content of two string objects to determine if they are equivalent. But notice the subtext that returns true if the objects have identical contents. Notice the usage right below it. Really what's happening is it's returning a true or false value. That's the result of it. So if I want to be able to use that true or false value, I have to understand that it's a Boolean. And that's that type of thing that we can use to do some of the homework. All right, so things are equivalent. What if we ignore case? Because the uppercase A is different than a lowercase a. So if I had apple with a capital A and apple with a lowercase a, it considers them different. It's kind of like, case sensitivity in a password, in essence. All right, take a look at the usage here. So we have a string called a name. Now remember, this is technically an object now. right? I mean, we treat it like a variable, but really it's an object. And then when we try to see if something is equivalent or not, we actually use a name dot equals. And the whole reason we can use the dot equals is because it is an instantiated class. It's an object. So we can call the object by name and apply a method to it that has been inherited from the class from which it was created. It was in the blueprint. In the blueprint, we have a thing called equals. Okay? Unlocking the door a little bit more? Maybe. Okay, I'm open. All right, so that's kind of the important part there. So here's another one. Compare to. Looks at two strings and returns different values. Now this is kind of interesting because you would want to think that it would be true or false, or yes, it's equal, no, it's not equal. But what it does is it looks at two strings and it returns a 0 only if two strings refer to the same value. Negative number if the calling object is less than the argument, and you guys should be scratching your heads there already, and a positive number if the calling object is more than the argument. So if I have the letter B, is A less than B? And is C greater than B? No, it doesn't depend. Actually, that's actually the case. Because when you look at the ASCII chart, so like when you press that key on the keyboard, every time you press it, it generates a series of electronic pulses that we can convert to ones and zeros, that convert to hex characters and base 10 characters. So each key on the keyboard has a numeric value. The numeric value for A is less than B, and C is greater than B. So if I compare, if it's less than or more than. So you can see the example. So here's an example of how you can use that. You can use a string called a word, compare it to another one, and then if the result is less than 0, meaning negative, it's less than the argument, and that might be useful for why would you even want to know if one is less than or more than the other? Think of a scenario. And think of what happens in your head. All right, whose name begins with the letter A? Okay, you got two people here. What's the second letter in your name?
L.
Okay, which one is greater than? Right? Right, so why would we use that? So we can alphabetize. There's just one simple example. All right, why would I need this? That's why. That's why some geek sat and wrote this. Because, we do things in our heads automatically. We don't give it much thought. And when you start to break it down and look at how it actually works, we have a little bit more of an appreciation of actually how complex the process really is. All right, can we have an empty string? Sure, sometimes we actually declare a string and put in empty quotes. We can also do null. It says strings are set to null by default. However, they cannot be used in string methods. So if I try to send a string to something that has a method that's like, switching it to uppercase, let's say, I can't send null in, it breaks. Doesn't know what to do with null. Okay, so that's kind of an important one. All right, here's a couple more. We've already seen these, right? 2 uppercase, 2 lowercase. That means to switch them to that. We have the length method. Now that one is actually kind of useful, and it's actually kind of a little bit of a clue to the fact that we're actually working with an array, right? Because if I have like 5 letters in the array or in the string, this is going to return the length. It's going to tell me how many things are, how long it is, basically. How many letters does that word have, or that sentence? One that goes kind of along with that, once again kind of proving that we're working with that kind of a data structure, is this thing called index of. When I have an array structure and I want to find a position in the array, what do? I look for the index value. We start counting at 0, 1, 2, 3, etc. Right? So maybe in my process of alphabetizing, Think about what I just did with Alana and Ashley, right? Are the A's the same? Yep. Second letter the same? Nope. One's an S, one's a L, right? What's the index of the second letter? 1, right? Because we start counting at 0. So you see how that works? So we can actually go through, and as a result of this method, we can look at individual characters inside the string to do a comparison. Does it end with an S? You know, that kind of thing. Interesting, right? Kind of go along with that. Here's another one. The character at, that one checks to see what character is at a particular location. So that can be kind of interesting. It says it requires an integer argument. What kind of integer would you put in here? So if I put Ashley's name into a string and I said character at 0, what's the return? A. It's the first character in the array. Character at position 0 is A. See how that works? Yeah, I see you're very thrilled with it. Okay. All right, here's the ends with and starts with methods. Those are kind of cool. We can also do a replace. So here's a scenario where you might use a replace. The person typed in their name. I forgot to capitalize the first letter. I can go in there, replace it with the capital. Or actually I could use it. Wow, you can do it so many different ways. It's crazy. Right, the other thing is that we could do something like this. ToString, we can take a number, this is an integer, and we want to put it into a situation where we can output it to the screen or whatever. We can use the ToString method to change it to a string and then use it with string objects and characters. You guys know how to concatenate already? We need to cover that one. Use the plus sign to concatenate. Okay. You almost got me there. Just got to stop with the jokes and people won't make them back at me. All right, this one's kind of cool too. And those of you that had Intro to Programming and VB, we had a little exercise on this with substrings. You remember that? And a substring is a portion of a string. And it takes two integers, the start position and the end position. So if I used Ashley's name and I did substring substring 0, 2, what would the result be? What's 0? A? Yeah, A and H. So the substring is everything from the beginning to the end, so it's Ash. That's a substring. See how that works? And they have a little example of it here, not worried about it too much. All right, region matches. That one's kind of interesting. You guys won't be using that in any of your work, but you know, it says two variants that can be used to test if two string regions are equal. So what do you think a region is? Know what a substring is? A region is, you know, kind of like a larger portion, so it might be a significantly larger amount of text, and it is going to return true or false. All right, this next little section talks about converting string objects to numbers. That's also built in, and notice we actually have an integer class that's different than the primitive data type int. So just like we have a car, a character, and the character class, really the point of it is mostly that we enable all these methods that we can use. So since it's part of the Java language, the core Java language libraries, we do not need to preface it with the class name. We still could and it'll work, but you don't have to. It says it's automatically imported in, converts a string to an integer. So if I type in the letter A, capital A, what number does it become? It depends on the ASCII code. Wrapper, that sounds like HTML, doesn't it? Yeah. It says a class or an object wrapped around a simpler element. And I don't know if they really have an example here of that. Let's look at a couple of these methods real quick. It says integer class value of. So it converts a string to an integer class object. So I take the string, it converts to an integer object. Now it's different than an integer because we're creating a new copy of the item. All right. So if you look at just a couple of these, and let me just ask you this: what does the word parse mean again? It's one of my favorite ones to ask. Help, Google, help. What is parse? What does it mean to parse? Oh, I left my parse in the car. No. That's very bad. Bad humor, sorry. Yeah, that's probably not it. How about, what does it mean to parse? I should probably pause the video at this point. Okay, so after a little bit of Googling, we came up with this. It says, parsing or syntactic analysis is the process of analyzing a string of symbols, either in natural language or in computer languages, conforming to the rules of a formal grammar or syntax for a programming language. It comes from the Latin, meaning to basically break things into pieces and look at them and read through them. So when I say I'm going to parse a file, I'm reading through the file. So when I parse and I'm parsing a double, what am I doing? I'm looking at that value and I'm reading through it and breaking it down. It takes a string argument and it returns a double value. So if I parse double and I type quotes 64, what does it do? It converts it to a number of type double. Okay, so why is that useful? Okay, here's the why. When you're running a program, like you prompt the user, how many cars do you want to buy? 1, right? When you type that number in, it's a character. So somewhere in that scanner class, the scanner class runs this. It goes, parses a number as a double, or let's say it parses an integer, whatever, and converts it to actually a number that we can use in the program as a number. When we type something in and we interact with the computer, it's actually a character. Then the program converts it to a number for usage. And they have an example here, but we're going to skip over it, because I think I already talked about that one a little bit too much. All right, a couple of important classes here. The string builder and the string buffer classes. It says the value of a string is fixed. It says after a string is created, it is immutable. What does that mean again? You can't change it. Okay. All right, string builder and string buffer are a way to do string-like things without using the string keyword. All right. Now it says use when a string will be modified. It says you can use anywhere you would use a string. So you could drop that in at any standard part of a program in place of the keyword string, and things will work just fine. Also part of the core language. All right, so why do we have two different ones? Well, string builder, it says it's more efficient. The code is more compact. It works very quickly and easily. However, the string buffer is thread safe, and it's used in multi-threaded programs. Now, I'm not going to quiz you on this one, but when you're writing a computer program, you execute it on your machine, do you think about the other computer programs that are running at the same time? Or within that program, how many threads are being executed? We don't think about threads, do we? Threads are little sets of instructions or programs that are running through the processor at the same time to kind of form a stream, basically, of things going on. Now, interestingly, we're going to be talking about multi-threading in Java 2, people. It's one of our upcoming chapters. And the reason, it's called thread safe, that means that the things are isolated and therefore will crash less if there's a problem. So if you opt for one or the other, if you're doing something very complex with a lot of things going on at the same time, you use StringBuffer, generally speaking. All right, so you can see if you're going to do a string builder, you can just say string builder, give it a name, say new, and instantiate it, right? We're creating a version. It is, replacing the string, keyword, but notice that we have to use new this time, where with the string class, we can kind of skip that. All right, here you must use new. It's a buffer. Ever hear anybody throw that word around? Oh, it's in the keyboard buffer. Did you ever hear that? Okay. Well, it's just a location in memory that things kind of get temporarily stored. So it says a memory block might or might not contain a string. The string might not occupy the entire buffer. And the length of a string can be different from the length of the buffer. So, okay, so I'm trying to find a convenient way to say this. But a buffer is just basically a spot that you store things temporarily before you utilize them. A buffer usually will be of a predetermined size. We may or may not fill it. What's in the unfilled portions from our perspective are irrelevant, but there's probably still things in those locations. You can also set the size of those buffers. All right, so some of the other things that we're going to do here, you can set length, and these go with both of these classes now. So you can change how long something is. So if I type in a string, it's got 100 characters in it, and now I want to make it 150 characters, I can do that. Even if I don't put something in those spots, right? But it grabs the space and it holds on to it for us. There is a length property, and in terms of a class, when they say property, that's one of those things I'll often call data fields that are at the top of a class file. And we usually say private, whatever, it'll be up at the top. All right, another one, the capacity method, we just check to see how big the object is so we know how many characters we can put into it. All right, I'm skipping over the example. You can tell I'm trying to rush to my PowerPoint. All right, so why do we use it? Improve performance over string objects. Most of us still will go with strings, but if we are writing a really large program, efficiency is important, because every little bit of processing power and speed that we can save makes for a better user experience. Nobody likes to sit there and wait. Some example constructors. And notice you can just do a string builder, no arguments. You can send in numeric values. You can send in strings. That's kind of interesting in itself, right? So it doesn't kind of care what data type it is almost, because it will do what? It will turn it into a string. All right, some other methods that we use. Append, add something to the end, insert, put it in the middle, or find a particular spot, set character at. So with Ashley's name, set character at 0, right? What's in 0 now? An A, and I switch it to B. All right, and once again, we see this character at, which works pretty much the same way as it does with the previous class that we looked at. We look at it as an array, we find the position, we extract the character. The syntax is the same despite the fact that we're using a different class. That's okay. That's absolutely acceptable. All right, he does his you do it's, don't do it's, which you can read on your own. And these are the things we looked at. We're basically done with the PowerPoint. And this video is done.